The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Okay, so we've got some questions that were requested this morning. So I'm going to start with those. And these are from yesterday's homework. They involve solving equations. The first one, and again, your problems may be different than these, but similar. First one is number 23. It says solve the equation. And the equation is P times the quantity P plus 1 equals 42. So what we've got here is an example where the left side is factored, but the right side is not 0. So the fact that the left side is factored is of no use to us. So I'm going to multiply that out. P squared plus P equals 42. I'll subtract 42 from both sides of the equation. P squared plus P minus 42 equals 0. So now the equation is in standard form. AX squared plus BX plus C equals 0. I see that it's a trinomial. It's in descending powers. There's no greatest common factor. It has a leading coefficient of a 1. It's not a perfect square, etc., etc., etc. So I'm going to factor it, pulling apart the first term. And then I've got a product that's negative 42 and a sum that's 1. So the numbers are going to be 7 and negative 6. So there it is factored. Then take each factor that contains a variable and set it equal to 0. And then solve each first degree equation. Subtracting 7, I get P is negative 7. Adding 6, I get P equals 6. So the two answers would be negative 7 and 6, respectively. Any questions about that before we go on to the next one? Okay, this one is number 27. Again, it says solve the equation. And the equation looks like this. Negative 24x squared plus 5 minus 26x equals 0. Well, the first thing I'm going to do is rearrange the terms on the left side of the equal sign so that they are in standard form. So negative 24x squared minus 26x plus 5 equals 0. Well, I've got a trinomial in descending powers. It doesn't have a leading coefficient of a 1. It's not a perfect square, but I think I'm going to take out a negative 1 factor. So negative 1, 24x squared plus 26x minus 5 equals 0. So now I've got a trinomial with a leading coefficient that's pretty huge. I'm going to use grouping. So A is 24, B is 26, and C is negative 5. The product would be negative 120, and the sum would be 26. So I'm looking for two numbers whose product is a negative 120 and whose sum is a 26. I'm going to rewrite those up here at the top of the page so I have more room to work with. Well, to get a negative product, I have to have a positive factor and a negative factor. Since my sum is positive, the two factors, the positive factor needs to be larger. So I've got a big positive factor and a little negative factor. So I'm going to try 120 and negative 1. Now, I knew going in that that wasn't going to be correct, but at least it gets me started. That gives me the right product, but that would give me a sum of 119. So I'm a long ways away from where I need to be. But 120 is an even number, so I could cut that in half and consequently double the -1 and make it -2. 6 times -2 is still the right product, -120. Now the sum is down to 58. So we're getting closer. Well, let's see. Again, 60 is even. Cut it in half, double the -2. I get 30 and -4. That gives me a product of -120 and a sum of 26. I hit it right on. So the numbers are 30 and -4. So now I'm going to rewrite the equation. I've got a -1 outside, 24x squared plus 30x minus 4x minus 5 equals 0. I'm going to use factoring by grouping inside the parentheses. So I've got -1. And then the greatest common factor here would be 6x. So this is going to be 4x plus 5. And this is going to be 4x plus 5. And a -1 outside. So the complete factorization, I've got a -1 times 4x plus 5 times 6x minus 1 equals 0. So now it's factored completely. Now there's something I've been saying yesterday, I said it quite a bit, but it never really mattered perhaps until now. And this is what I've been saying. Once you've got it factored completely, take each factor that contains a variable and set it equal to 0 and solve it. Well, what about this factor? Well, that doesn't contain a variable. -1 equals -1. It wouldn't make any sense to say -1 equals 0 because it doesn't. But then you might say, well, what do we do with that -1? Well, what we could do, we could divide both sides by -1, which would in effect get rid of it over here, and this would still be 0. So basically, I'm going to ignore it because I could divide it out and I'd still have the factors containing variables set equal to 0. Okay, I'm going to take this and copy it on the next page so that I have more room to write. So I've got 4x, let's see, plus 5, and then 6x minus 1 equals 0. So again, I divided both sides by that -1. Okay, so now I'm going to take 4x plus 5 equals 0 and 6x minus 1 equals 0. Solving the first linear equation, I will subtract 5 from both sides of the equal sign and then divide both sides by 4. So x is -5/4. There's one of the solutions. The second equation, I'll add 1 to both sides. 6x equals 1. Divide both sides by 6, and x equals 1/6. All right? And be sure to follow the directions in WebAssign to write the answers separated by a comma. Okay? So like -5/4, comma, space, 1/6, like that. All righty. And we've got one more that was requested. I can't talk today. How is that any different from any other day? Okay. It says factor the expression. This is part A. Factor the expression. 4a squared minus 12a. So factoring that, we would take out the greatest common factor, which is 4a, and have a minus 3 left over. Okay. Part B says solve the equation 4a squared minus 12a equals 0. Well, I've got the left side of the equation equal to 0 on the right side of the equation, so it's already in standard form. Factoring the 4a squared minus 12a, we're going to get the same factors we got in part A over here, but now it's set equal to 0. So take each factor that contains a variable, set it equal to 0, and solve it. If 4a equals 0, divide both sides by 4, a is 0. If a minus 3 equals 0, add 3 to both sides, a equals 3. So the answer to part B, those two solutions. The answer to part A, just factoring. We can't solve part A because it's not an equation. We can just factor it. But part B, we were asked to solve it. Any questions about that? All righty. With that, we're going to go on to 6.8. So here we go. All right, in 6.8, we're going to be doing some story problems or applications, and we'll be using this solving equations, this factoring method, etc., etc. All right. First problem I want to do, it says flags, F-L-A-G-S. And we have this picture of a flag. And it's got a flagpole here. And anyway, it's got some designs on it and everything. And anyway, we've got this flag. It says the length of the flag of Australia is twice as long as the width. Let's call this the length and this the width. It says the length is twice as long as the width. The length is being compared to the width. So if we call the width x, the length would be twice x, or 2x. Okay? So the width is x, the length is 2x. Any questions about where I got that? All right. It says find the dimensions. So we want to find the length and the width of the Australian flag if its area is 18 square feet. Okay. We have a rectangle. The formula for the area of a rectangle is area equals length times width. We're told that the total area is 18 square feet. So 18 square feet equals 2x times x, the length times the width. Any question where I got any of that information? So cleaning that up, I get 18 equals 2x squared. So this is a second degree equation. So I'm going to put it in standard form, put everything on one side of the equation, set equal to 0. It doesn't really matter which side of the equation is 0, but I'd like to have my leading coefficient positive. So I'm going to subtract 18 from both sides, which gives me 0 equals 2x squared minus 18. And I could have just as well have written 2x squared minus 18 equals 0. Okay. Well, I see that I can factor a 2 out of both terms on the right side of the equation. And then I see that I have the difference of 2 squares, x plus 3, x minus 3, left over. So now I've factored the equation completely, set equal to 0. So my next step would be to take each factor that contains a variable and set it equal to 0. Well, here again, I've got this 2, and I can divide both sides by 2 and still get 0 equals x plus 3 times x minus 3 if I want to, okay? Or I could just ignore it in terms of setting each factor that contains a variable equal to 0. So now I've got x plus 3 equals 0. X minus 3 equals 0. If x plus 3 equals 0, subtracting 3 from both sides of the equation, I get x equals negative 3. If x minus 3 equals 0, I add 3 to both sides of the equation and get x equals positive 3. Now, negative 3 and positive 3 are both solutions to this equation. However, length and width, those are both distances, and we can't have a distance that's negative. So even though this answer fits as a solution to this equation, it doesn't fit in terms of being a length or width for the flag. So x equals 3 is the only solution. Since the width is x, the width is going to be 3. The length is 2 times 3 or 6. However, we need units, which were feet. So the length is 6 feet and the width is 3 feet. Be sure to include the proper units on the answers. Sometimes in WebAssign, it has a box for the number and that it has the units written outside already, but just make sure that if they're not there and you need them, that you do include them. All right. Any questions about this particular example before we go on?
Where do you get the 6 from?
Sorry, I couldn't hear you, Paula, because of the children noise. Say that again.
Where did you get the 6 from?
Okay, the length was 2x. So the length would be 2 times the 3. Since x is 3, 2x would be 6. Does that make sense?
Yeah. Yeah.
Okay. All righty. We good to go on?
Yeah.
Okay. Let's see. This next problem, it says jeans, as in blue jeans. The height of the triangular shaped logo on a pair of jeans is 1 centimeter less than the length of its base. If the area of the logo is 15 square centimeters, find the length of the base and the height. Okay, so we've got this triangle. Okay, and this is it's a logo that's sewed onto a pair of jeans. Okay, it says, what does it say? The height is 1 centimeter less than the length of its base. All right, so for a triangle, this distance would be the height, and the base down here is this distance, which could also be called the length. It says the height is 1 centimeter less than the length of its base. So if the base is x, the height would be x minus 1 centimeter. Again, the height is 1 centimeter less than the base. So the height is being compared to the base. So the base is sort of the center of the universe for the problem. We're going to call the base x. The height is 1 centimeter less than x. Okay. Now, they also tell us that the area of the logo, so this inside area, is 15 square centimeters. Now, the last problem we had a rectangle. This is a triangle. The area of a triangle is 1/2 the base times the height. Okay. So in this case, the area is 15, the base is x, and the height is x minus 1. So that gives us that equation. Now, I don't know about you, but I don't particularly want to have to distribute the 1/2 through everything. So what I could do to get rid of it is I could clear the fractions by multiplying both sides of the equation by the least common denominator, which is a 2. So I'm going to multiply that side by 2 and that side by 2 as well. So I now have 30 equals 2 times 1/2 is 1. 1 times x is x. So then I get 30 equals x times x minus 1. Any questions about what I just did there? Okay. Next, I'm going to distribute the x, so I get x squared minus x. Then I'm going to subtract 30 from both sides so that I have my equation in standard form. 0 equal to a trinomial in this case. That trinomial is in standard form. There's no greatest common factor to take out. It's not a perfect square, but it does have a leading coefficient of a 1, so it's going to factor x and x. Let's see, the product is going to be negative 30 and the sum is going to be negative 1. So how about negative 6 and a positive 5. So there it is, factored completely, okay? So now I'm going to take each factor that contains a variable and set it equal to 0. So x minus 6 equals 0, x plus 5 equals 0. All righty. Take each equation and solve it. So I'm going to add 6 to both sides of the first equation, x equals 6. I'm going to subtract 5 from both sides of the second equation, x equals negative 5. So x is 6 or x is negative 5. Those are both solutions to the equation that we created. However, again, in this case, we're dealing with distances. Height and the length of the base are both distances, so they can't be negative. So if x is 6, the base would be 6 and the height would be 6 minus 1 or 5. However, we still need the units. Well, the area was given in square centimeters, so the length of the base and the height would both be centimeters. So the base is 6 centimeters and the height is 5 centimeters. Any questions about that? All righty. Let's take a look at another example. And let's see here. This has to do with consecutive integers. So first of all, let's talk about integers. Remind you what they are, integers. So integers are like 0, 1, 2, 3, 4, 5, etc. But going the other direction, negative 1, negative 2, negative 3, etc. So those are integers, okay? They are whole numbers and they're opposites. All right? Now, consecutive integers. Would be like, well, in fact, this is consecutive integers. Consecutive integers go up by 1. So let's say we had, let's see, what does it say? Let's say we had 2 consecutive integers. So the first consecutive integer and then the second consecutive integer. If the first one was x, the next one would be x plus 1. And the next one would be, oops, I wrote x plus x, my bad. Would be x plus 1. The next one would be x plus 2, etc., etc. Those are consecutive integers, one right after the other. All right. Now, what about consecutive even integers? Well, that would be like what? Here, let's see, negative 4, negative 2. Well, in fact, let's go back here. These would be consecutive, right? Negative 2, 0, 2, 4. How far apart are consecutive even integers? They're 2 apart. So if the first one was x, the next one would be x plus 2, and the next one would be x plus 4, etc. Okay? So consecutive integers are 1 apart. Consecutive even integers are 2 apart. Well, what about consecutive odd integers? Negative 3, negative 1, 1, 3. Those are also 2 apart. So if we were dealing with consecutive odd integers, the first one would be x, the second one would be x plus 2, etc. And you might be confused going, how can an odd integer be x plus 2? Well, if x is odd, what's an odd integer plus 2? It's still the next odd integer. Okay, so consecutive integers go up by 1s. Consecutive odd integers and consecutive even integers go up by 2s. Okay, so now let's take a look at this next problem. Give you just a second there to finish writing stuff down. All righty, thank you. It says NASCAR, N-A-S-C-A-R, NASCAR. The car numbers of drivers Casey Kane and Scott Riggs are consecutive positive integers whose product is 90. If Kane's car number is the smaller, what is the number of each car? All right, so we've got Kane and Riggs. Kane's is the smaller number, so that's going to be X. It says that they are consecutive positive integers, so Riggs would be X plus 1. Okay. It also says their product is 90. So that means X times X plus 1 equals 90. Any questions there? All right. So we get X squared plus X equals 90. We subtract 90 from both sides of the equation. X squared plus X minus 90 equals 0. So now our equation is in standard form. On the left side of the equation, there's no greatest common factor. It's not a perfect square. Leading coefficient of a 1, so X and X. Product is negative 90. The sum is 1. How about plus 10 and minus 9? Okay. So now that it's factored completely, we'll take each factor that contains a variable and set it equal to 0. X plus 10 equals 0. X minus 9 equals 0. We'll solve each first degree equation. The first equation, subtracting 10 from both sides, X equals negative 10. The second equation, adding 9 to both sides, X equals 9. So again, we get two solutions to our second degree equation. However, the directions said, let's see, they're consecutive positive integers. So once again, we're throwing out the negative value. So X is 9, X plus 1 would be 9 plus 1, which is 10. So Kane, number 9, Riggs, number 10. Long before this was a hashtag, it also meant number, okay? All right, now, there's been a pattern, and I want you to be careful. The pattern has been that the last 3 problems we did, every one of them we came up with 2 answers, a positive and a negative, and every one we threw out the negative. But that's because we were dealing with distance or positive integers. Distance and time are both 0 or positive. So in those contexts, we won't have negative answers. But be careful. I can still remember a tragic situation. A student that took a test from me years ago. On this particular test, there were a whole bunch of problems involving solving equations. And then there was a problem at the end that had to do, it was a story problem. And you came up with 2 answers and you kept the positive and you threw out the negative. Well, when the student did this, something in his mind clicked or snapped or whatever, and they went back to all the previous problems where they had just solved equations and they crossed out all the negative answers. This was not a good strategy, okay? Those first problems where you're just solving an equation could very well have negative answers. But in the context of a story problem where the answer, if it's an answer that has to be positive, that's when we'd throw out the negatives, okay? I've seen story problems where you got 2 answers and you kept the negative and you threw out the positive. So you've got to consider, what are we using those answers for? What is the problem asking for? So just be careful with that, okay? All right. Now, we've dealt with problems that had consecutive integers. We've looked at a problem with area of a rectangle, a problem with area of a triangle. Now we're going to look at some problems involving triangles where it's not so much the area of the triangle, but the length of the 3 sides of a triangle, okay? When we have a right triangle, that is a triangle that has a right angle, there are special names given to those sides. The longest side is called the hypotenuse. Let's see if I'll spell that correctly. Let's see, noose. And the other two sides are called the legs. Okay. The longest side, which is the side across from the right angle, is always called the hypotenuse, and the two other sides are called the legs. As far as labeling them, the hypotenuse is always called C, and the other two legs are called A and B. Okay, it doesn't matter which leg you call A and which leg you call B, but the hypotenuse has to be C. When you have a right triangle, the following situation is true. The length of A squared plus the length of B squared equals the length of C squared. Okay, this is called the Pythagorean theorem. I'm sure I probably won't spell Pythagorean correctly, but this is called the Pythagorean theorem. Whenever you have a right triangle, the length of this side squared plus the length of that side squared equals the length of the hypotenuse squared. We're going to be using that formula on the next couple of problems. All right. So let's see here. I'm going to do this next. It says, okay, the problem says wind damage. A tree was blown over in a windstorm. It says find X, then find the height of the tree when it was standing upright. All right, so let's see if I can draw a decent picture of a tree. I want some brown. So we've got the ground here. Okay, and here's part of the trunk. And then it broke off. So we've got a piece of the trunk here. And then we've got this tree. Now you know why I don't teach art classes. Let's see, actually it's bigger than that. Okay, all right. So we've got this tree that was blown over in the windstorm. This side, let's see, where is it? This is called X. This is called X plus 2 feet. And this is called X plus 4 feet. All right. Now, what I want to point out is that this piece of tree trunk that's still standing, and then this piece of the tree that's broken and is hitting the ground is forming a right triangle. So what we've actually got there, whoops, is a lousy drawing. Okay, let's see if I can do a better job than that, maybe. Where this side is X, this side is X plus 4, and this side is X plus 2, and they're all in units of feet, okay? That's the idea. We've got this right triangle. Now, it says a tree is blown over in a windstorm, find X, and you've probably all seen that cartoon where somebody circles and goes, it's right there. That's not what they want. They want us to get the actual numerical value of it. Then find the height of the tree when it was standing upright. Okay. Which of the sides is longest? X, X plus 2, or X plus 4?
X plus 4.
Right, so that's the hypotenuse. That's going to be C. The other two sides we're going to call A and B. Okay, and again, it doesn't matter which side is A and which side is B. So using the Pythagorean theorem, A squared plus B squared equals C squared, we get X, the quantity squared, plus X plus 2, the quantity squared, equals X plus 4, the quantity squared. Any questions before we continue? All right. X squared is just that, x squared. X plus 2, the quantity squared, is x plus 2 times x plus 2. And x plus 4, the quantity squared, is x plus 4 times x plus 4. So now we're going to have to FOIL things together. We've got x squared, and then we're going to get what? Plus x squared plus 2x plus 2x plus 4 equals, over here, we're going to have x squared plus 4x plus 4x plus 16. Any questions there? Just a reminder, if you have something like this, that is not equal to x squared plus 2 squared. It's equal to x plus 2 times x plus 2, and then you have to FOIL it together. Okay. I'm now going to simplify the left side of the equation, combining like terms. 2x squared plus 4x plus 4 equals, combining like terms on the right side of the equation, x squared plus 8x plus 16. I can see that this is a second degree equation, so I want to put everything on one side of the equation set equal to 0 on the other. It would be nice to have my leading coefficient positive. It'll just save me a step of having to maybe factor out a -1. So I'm going to put everything on the left side, because 2x squared on the left minus an x squared would still give me a positive 1x squared. So I'm going to subtract x squared from both sides. I'm going to subtract 8x from both sides, and I'm going to subtract 16 from both sides. That gives me x squared minus 4x minus 12 equals 0, because these would all cancel out. So now I have a second degree equation in standard form. On the left side of the equation, I've got a trinomial, and there's no greatest common factor. It's not a perfect square. It has a leading coefficient of a 1. So I'm going to factor it with an x and an x. Let's see, I need a product that's -12 and a sum that's -4. How about -6 and 2? I think that will do it. So -6 and +2. So now I've got x minus 6 equals 0 and x plus 2 equals 0. If I add 6 to both sides of that first equation, I get x equals 6. If I subtract 2 from both sides of the second equation, I get x equals -2. Once again, x is a distance. So once again, I'm going to cross out the negative answer. I know what you're thinking. You're thinking there's never going to be a story problem with a negative answer. No, that's not true. Just this particular section, it is true. All right. If x is 6, then going back up to the tree, this would be 6 feet. X plus 4 would be 6 plus 4, which would be 10 feet. And x plus 2 would be 6 plus 2, which would be 8 feet. So we've got a 6-foot piece of stump, a 10-foot piece of tree that's broken off, and the base of the triangle is 8 feet. Okay. What's 6 squared? That's 36. What's 8 squared? That's 64. What's 36 plus 64? That's 100. What's 10 squared? That's 100. So for our triangle, a squared plus b squared equals c squared. Now, but the final answer, they want to know the original height of the tree before it was broken over by the wind. So we'd take this piece of the trunk, which is 6 feet, plus the tree, and we'd get 16 feet. So the final answer, the tree is 16 feet tall. Oh, it said to find X. Let's see. So X was 6 feet, and then the final, the height of the tree originally was 16 feet. All righty. Any questions about that? Okay, so keep in mind the formula for the area of a rectangle, area is length times width. The formula for area of a triangle, area equals 1/2 the base times the height. And when you're dealing with a right triangle and the lengths of the sides, a squared plus b squared equals c squared. Okay, let me stop the sharing. I'm going to turn off the recording.